Have you ever stopped to think that your morning cup of coffee might have a secret connection to a tea farm like halfway across the world? They seem like totally separate things, right? Well, today we're going to uncover this sort of invisible economic string that ties them together. It all starts with a simple little puzzle.
And here it is. It sounds like a riddle, doesn't it? A problem with tea makes your coffee cost more. How on earth does that happen? Well, it's not magic, I promise. It's economics, and we're going to solve this mystery step by step.
And we've got a roadmap to get us there. We'll kick things off with our puzzle, then I'll introduce you to a really powerful three-step method. And then we'll put it all into action to see exactly how these two markets are connected and why it hits you in the wallet.
Okay, so before we can crack this case, we need the right tools. And in economics, that means getting a handle on a couple of key ideas that explain how markets, and all of us in them, actually behave.
So the first and probably most important tool for our puzzle is this idea of substitutes. Let's break down this definition because it's crucial. When the price of one thing goes up, people start wanting more of the other thing. Coffee and tea are the perfect example. I mean, think about it. If your favorite tea suddenly costs a fortune, what are you going to do? You might just decide to grab a coffee instead. They're substitutes.
Our second tool is equilibrium. You can think of this as a market's happy place, its perfect balance point. It's that sweet spot where the amount of stuff sellers want to sell is exactly the same as the amount of stuff buyers want to buy. At that point, the price is stable. No shortages, no surpluses. Everybody's, well, content.
All right, we've got our tools. Now let's bring in our guide for this little journey. This is a simple but honestly an incredibly powerful way that economists figure out how some event is going to shake up a market.
And here it is, the three-step method. It's super straightforward. First we ask, does our event, that bad tea harvest, affect the buyers, which is demand, or the sellers, which is supply? Second, we figure out which way that pushes the curve on our graph. And third, we just look at the diagram to see what happens to the price and the amount being sold. Simple, right? Let's give it a try.
Now, here's where it gets interesting. The problem started in the tea market, right? But what we're actually going to do is track the ripple effects over into the market for coffee. Let's see how that plays out. So, let's start with our before picture. This is the coffee market on any given normal day. You've got the supply curve going up, the demand curve coming down, and right where they cross, that's our equilibrium. This gives us our starting price, we'll call it P1, and our starting quantity, Q1. For now, everything is perfectly balanced.
Okay, now for the action. The bad harvest happens and tea gets more expensive. So let's fire up step 1 of our method and figure out what this does to our graph.
Let's think this through. Does the price of tea change how much it costs a farmer to grow coffee beans? Nah, not really. But does it change how many people want to buy coffee? Oh, you bet it does.
And this chart shows us exactly why. See, a change in the price of coffee itself would just move us along the existing curve. But other things, these outside forces like the prices of related goods, they cause the entire curve to shift. Since our event is about the price of tea, a related good, it's going to be the demand curve for coffee that makes a move.
Okay, we've got our first piece of the puzzle. The demand curve shifts. Now for step 2, which way is it going? Is it moving left or is it moving right? Well, this is pretty intuitive. Since tea is more expensive, people are going to switch over to coffee. And that means that at any price you can think of for coffee, more people want to buy it now than they did before. An increase in demand on a graph always means a shift to the right.
And here's exactly what that looks like. Our original demand curve, D1, has now been pushed over to become this new curve, D2. That visual jump represents thousands, maybe even millions of people, all making a new choice, picking up coffee instead of tea.
We're almost there. We're at the final step. We've shifted the curve. Now we just need to see where everything lands. What's the new final result?
So let's trace it out. At the original price, P1, way more people want coffee than there is coffee available. That creates a shortage. And what happens when there's a shortage? Buyers start competing, and that pushes the price up. As the price rises, sellers are happy to supply more. So we move up along the supply curve until, bam, we hit our new demand curve, D2. And this gives us our brand new equilibrium, a higher price, P2, and a higher quantity sold, Q2.
And there you have it, puzzle solved. A bad tea harvest makes tea more expensive, which makes people demand more coffee, and that increased demand is what ultimately pushes up the price of your morning brew.
So why does any of this matter? What was the point of drawing all those curves? Well, because this simple little example reveals a really fundamental truth about how our economy is all connected.
So what's the big takeaway? It's that markets don't live in little bubbles. The prices of things that can be substituted for each other, like coffee and tea or maybe burgers and pizza, they're linked. A shock in one market sends ripples into another. And by using a simple tool like our three-step method, we can actually understand and even predict those changes. Prices are basically these silent signals that guide all of our decisions, every single day.
And that brings us to one last question for you to think about. What other substitutes in your life are tied together by this invisible economic string? Is it butter and margarine? Driving your car versus taking the bus? Netflix versus going to the movies? Once you start looking for it, you'll start to see these connections everywhere.